All right, for slope day 3, we are going to take a look at what happens when we actually don't have a graph here. And what I had you do was actually watch a quick review of subtracting integer rules. So we're going to just do a general overview of all the integer rules here. So for example, if I have a -4 plus a 7, that is going to give you a +3 because there's 3 more of the positives then when you compare the two. If I have 4 plus a -7, it's kind of the opposite version here where we have the 7 is negative, so there's more negatives, so our answer is going to be a -3. If I have 3 minus 6, remember I'm going to make 2 marks, adding the opposite. I'm going to get a -3 for my answer here then, because I'm finding the difference, and the difference is 3, and there's more negatives. In the example of 3 minus a -6, I'm going to go ahead and make those 2 marks again. So 3 plus a +6 is actually a 9. If I have -3 minus a 6, -3 will stay, add the opposite, so it's going to give me a -9. And then the last example, if I have -3 minus a -6, again, stay, make 2 marks, and I'm going to end up with a +3 for my answer. So that's your quick integer review. We're going to use that today. On the graph, we find slope. And when we're finding slope on the graph, we are comparing the rise over the run, so the vertical change compared to the horizontal change. Our problem becomes, though, if the coordinates are too large to accurately plot on a graph, and sometimes we just don't want to waste time to actually make that picture and count them up. So if we go back to the definition of slope, the slope is the ratio of vertical change to horizontal change. So the slope formula can also be defined like this: the delta y over the delta x. And this delta symbol is actually a Greek letter, and it really means change in Greek. So we're talking about the change in y over the change in x. And changes in y's are your vertical changes, and your changes in x are your horizontal changes. What we'll do is, if we have 2 ordered pairs for our points, we'll actually identify them as x1 and y1 and x2 and y2. So we'll actually find the difference between the 2 y coordinates. And then in the same exact order, we'll find the difference between the 2 x coordinates. This formula is found on the back of your formula sheet then. So we'll be using that moving forward. So for example, in this first one, we have 2 coordinates here. I'm going to call this x1 and y1. So the x coordinate and the y coordinate of the first pair, and the x coordinate and the y coordinate of the second pair. So I can plot these on a graph, 2, 5, and 0, 1, and I would be able to actually take a look at the line that's made between the 2 of them. And when I look at that line here, we would be able to count the rise over the run, but like we said before, we're not always going to be able to do that and not always going to want to do that. So when we talk about our slope here, we are going to find the difference in the y's, and we're going to start with y2 minus y1. So I'm going to do 1 minus 5. And then for the x's, I'm going to do that on the bottom. I'm going to do 0 minus 2. Since I'm subtracting, I'm going to follow my integer rules, add the opposite, add the opposite. So 1 plus a -5 will give me a -4. 0 plus a -2 will give me a -2. And -4 divided by -2 is going to actually give me a +2. So on my graph, that would be a rise of 2 and a run of 1, because I would express 2 as 2 over 1. So from this point, if I go up 2 and over 1, that puts me on the line. Up 2 and over 1 again, that still keeps me on the line. So the slope of this line is going to be a 2. And there you go. So that's how you find slope between 2 points. We're going to break this down today into the delta y and the delta x first, and then we'll go ahead and put it to slope for the first 2 examples, and then from there we'll kind of take away that scaffolding. So I'm not going to label these every time, but I'm going to do delta y. I'm going to do 8 minus 1. And for the delta x, I have to stay on the same pattern, so I'm going to start here and do 4 minus 7. 8 minus 1 is 7. 4 minus 7, I'm going to add the opposite and get a -3. So when I compare my delta y to my delta x, I'm going to have 7 over a -3. Since we have one negative, our answer will stay negative, and I'm just going to pull that out front then. In this next example, go ahead, find delta y. For delta y, you're going to do 5 minus 2. So your delta y value is going to be 3. Go ahead, take a minute, find delta x. For your delta x value, you're going to do 3 minus a -8. So you're going to make those 2 marks, and 3 plus 8 is 11. What would be your slope then, comparing delta y to delta x? Slope would be 3 over 11, and that is reduced, so that is your final answer there. For our next example, you'll notice we took away the delta y and delta x, so we're just going to start off m equals. I'm going to still show my subtraction problem. So for my y's, I'm doing 3 minus a negative 5. And for my x's, I have 7 minus 5. Using my integer rules, add those together. That's going to give me an 8. And 7 minus 5 is 2. So 8 divided by 2 is a positive 4. So my slope is just 4. In the next example, we're going to start off m equals. I'm going to show my work for 8 minus 9 over 1 minus 3. Integer rules results in a negative 1. Integer rules results in a negative 2. A negative divided by a negative will give me a positive, and it's already reduced, so my slope is 1/2. Go ahead here on this next example, write out your m equals, showing your subtraction problems, and then you'll go ahead and figure out what is your final slope. So for this one in the first part, I'm going to do 6 minus 2, and on the bottom, 5 minus a negative 4. 6 minus 2 will give me 4. 5 minus a negative 4 will give me 9. So my slope is 4/9. For the last example, my slope is going to be negative 10 minus 1 and 3 minus 2 for my delta x's. Adding the opposite results in negative 11 over 1, which will give me a negative 11 for my final slope.